We download the program CropET from the webpage of the University of Córdoba. We can take it, we can download it in different languages. We're gonna download English. We can right click and save link as, and then we put it in any folder or of our hard drive. For instance, here, click on save, and then we can access. And to run the model, we just click on that, and then the program will open. First, if we are on a southern latitude location, we should click here. If we want the US format for dates, we should click here. We're gonna produce a rotation of maize. Click on M. We have all crops with the M, starting with M. And then for this crop, we have different alternatives for different types of climates, continental, Mediterranean, etc. We're gonna do a Mediterranean grain maize starting, in this case, on day of year 120. This is around the 1st of May. With these durations, we can always edit any of these values. We can change the maximum ground cover if we want, and then we can edit the price that we get for our crop. Then we can add more crops, for instance tomato, and then we're gonna grow a tomato crop starting also on 120 with these durations, and the price for tomato is gonna be, say, $30 per ton. Click on proceed. If this is the first time that we run the program, then we don't have weather files in the folder weather. We can generate weather clicking here, and then we select the country. In this case, we go to Spain, and in Spain we're gonna choose Badajoz, and now we can select a different number of years other than 30, and we can also change the average temperature or change the rainfall in a given percent. We're gonna keep actual values, so we click on generate daily weather data, and then we see that Badajoz Gen has been added to folder weather, and these are the variables. All the variables required for calculating evapotranspiration are generated. Click on OK. We go to calculate ET, and here we have now one weather file, Badajoz. We click here. It will automatically update the latitude and the altitude of the location. We choose the soil type, and in case that we have storage of soil water during the winter that we can deplete during the irrigation season, we should click here, and then we go to calculate, and it will provide values for grain maize yield, and for tomato the yield, and these values can always be edited. Imagine that we think that this value is too high. We could put here 90,000 kilograms per hectare, and then we go to irrigation, and here in irrigation we will add information regarding the irrigation system and the water. For instance, we can, in this case, use sprinkler irrigation with not desalinized water, and these are the default values for application losses, uniformity coefficient, allowable depletion during the season, electrical conductivity of water, and the electrical conductivity of the soil at the start of the growing season, cost of energy and cost of water, pumping depth and pump efficiency. We click on calculate, and it will give us the net irrigation required and also the irrigation that has to be applied to meet this net irrigation requirement. This the ratio between those two is shown in this column. So for this irrigation system, the optimum would be irrigating with a ratio of net to gross irrigation around 80%, and we would reach the maximum yields. The yields in the previous screen were calculated according to intercepted radiation. So sometimes they can be somewhat off. So we can always edit if we know the values of maximum yield in that area. We can then go to show results. Here a text file is created called results.txt showing the inputs and the outputs, and then we can go and exit the program. Anytime we run the model, a number of files will be created showing, for instance, the distribution functions for rain, the average ETO during the growing season, or the crop water requirements and the distribution function for the two crops, and the annual values of the main variables in the calculation of crop water requirements, like ETO, ET during the growing season, effective rainfall, crop water requirements, maximum yield, or rainfall during the growing season. And this is calculated for each of the years that we have weather data.